So let's begin our discussion of seventh grade mathematics with circles. So in our circle, we have two things measured for us. We've got an R, we've got a D. What the heck is R? Of course, our R is equal to the radius. R equals radius, which of course is the distance from the center to the circle. When we say circle, this is the circle. It's this black outline that's right here. It is not the blue part that's on the inside of that. That's actually a disk. So this is a circle. So often people say, oh, it's the distance from the center of the circle to the edge of the circle, the outside of the circle. No, you don't have to use that kind of terminology. It's just the circle. And then we have the D part here, and the D is our diameter. Diameter is measuring all the way across our circle. It goes through the center, of course, and if we visualize this as being a radius, and this one on the left-hand side also being a radius, we can see the relationship that our D is equal to 2 times the length of the radius. In terms of lengths, it doesn't mean in terms of the segment, because if you look at this segment, which is radius, and this one, that's 2 radii, plural of radius is radii. That's 2 radii that do not make a diameter. Okay, now that's all out of the way. C here stands for the circumference. Circumference means the same thing as perimeter. It's just whenever we have a curvy shape, we use the word circumference instead of the word perimeter. And there's two different formula that are associated with the circumference of the circle, depending on what you have. If you're given the radius, that's equal to 2 times pi times the radius. And as we just mentioned over here, the diameter is equal to 2 times the radius. So we could take the 2 and the 2 and the r out, pop them right out, and then make that equal to pi times diameter. Both of these formula will give you exactly the same answer, the circumference of that circle, and you just choose the appropriate formula based on what it is that the problem gives you. Did they give you the diameter or did they give you the radius? That's how I'm going to choose. Okay, and then area. Area now is the blue part that's inside there. Essentially, just like the previous video stated, what you'd be looking for is how many squares it would take to fill that thing up. If you could get like an actual whole number of squares, you probably aren't going to get a whole number of squares because this thing is irrational. We'll talk a little bit more about that in just a second. Area formula here is pi r squared. Now these two formula get confused very, very frequently, and you can see probably why. They have the same stuff in them. You got 2's, you got pi's, and you've got r's. However, this 2 is being squared here, and this is a 2 that's being multiplied times all of that stuff. Even worse, I sometimes see this, 2 pi r squared. To combine up both of those formula, don't be that person. Okay, now, each one of these formula have a pi in it, right? A pi, what the heck is pi? Let's talk a little bit about pi. Pi is an example of an irrational number. Irrational means not rational, the opposite of rational. What is a rational number? Here, let's talk about that for a second. Rational. Rational, its root word is ratio. And so a rational number is a number that can be written as a ratio of integers. So it's A over B, where these two guys, this A and this B, are integers. And remember, integers are positive, negative whole numbers, 0, of course, no fractional bits, and no square roots and stuff like that. Okay, so this down here is also an integer. So you got stuff like, 1/2, 3/4, 2/3, and so on. All of those things are examples of irrational numbers. Rational numbers, I should say. So the exact opposite of that, when we say that a number is not rational or irrational, we're saying that you cannot write it as a ratio of two integers, A over B. So an example of that, of course, would be something like pi. You can't write that as a ratio of integers. And people have tried and failed. For example, 22 over 7 is one that is super famous. Here, let's come over here to the calculator. I'm going to use my little pi button, hit enter on it. And now understand that even though the decimal place ends at a 4 on the far right-hand side of the screen, it doesn't end there. It goes on forever with no discernible pattern. And then if I take, let's say, 22 divided by 7 and hit enter on that one, and if I compare these two things, the 3.14 matches up, but then everything after that is not going to match up. So a key difference between these two things is that pi has a non-repeating decimal, a non-repeating, non-terminating decimal, whereas the 22 over 7 as a rational number is going to repeat at some point. When you divide by 7, it's pretty kooky. It's 1, 4, 2, 8, 5, 7, and then it's going to start repeating again after that. 1, 4, this 3 is actually the 2 that's rounded up because of the 8 that's after it. So it'll repeat after some kind of pattern, or it stops. Like, for example, 1/2 is just 0.25. So that's another thing about irrational, is that decimals go on forever and don't repeat. Decimals non-repeating, non-terminating. Terminate means to stop. Okay, now as far as this pi goes, and this 22 over 7, again, we want to say this kind of thing is not equal to. It is also often approximated by 3.14, and just to be clear, you don't write this, because now you're saying that it is equal to some kind of rational number. You could write this as a ratio of integers because the decimals stop. Instead, what we do is we put the little squiggly lines, and the two squiggly lines means approximately equal to. Now, this is really important in honors geometry because we will often have problems where we have to write either an exact answer or an approximate answer. So here, let me explain the difference between those two things. Let's say that I have a circle whose radius is equal to 2 inches. And I want to find both the circumference and the area of those two things. So the circumference is equal to 2 pi times my radius. And commutative property says that the order of these things do not matter. So you can multiply this 2 times this 2 and get 4, and then just tag the pi to it. So this is 4 pi. And you remember from, let's say, algebra, you can kind of treat this pi like it's a variable. You just leave it alone. This is the exact form of this answer. This is exact. And actually, I left one thing off, and that's the units. This should be inches. Okay, but let me go ahead and write that this is the exact form of this. And as soon as I put it into the calculator, I'm going to get an approximation. So let me pull my calculator back up right here, and I'm going to take 4. Don't use 3.14. Always use the pi key that's built into your calculator. Here it is right there. If they're put side by side, we know that that means multiplication. Hit enter, and that 1 that's on the far right of the screen, that's not the last decimal. It goes on forever. Where are you supposed to stop it? That's the reason why we like the approximation. Here, I'm going to put this as 12.566, and it's approximately that, which is approximately 12.566. Those things go on forever, again, in inches, and we call this thing the approximate answer. It's still really accurate, but it's not as exact as the pi. Now, the benefit of this is that you don't need a calculator to find 4 pi. You just write it like this as one complete answer. This one needs a calculator, and then if you have to use this in a further calculation, then you have to take into account all these decimal places, and then you're going to start introducing some rounding errors. And so the benefit here is that you don't have to worry about any of those things with the exact form of the answer 4 times pi. All right, now one last thing about this. This kind of goes with the previous discussion on a perimeter versus area. Let's say that I'm going to find the area of the same exact circle. So pi times 2 squared. 2 squared is 4. 4 pi. And remember, I'm just leaving this as an exact answer like this. 4 pi. No need to put that into the calculator. If I did, I'd get the same exact number right here. But this one also needs inches squared. So let me ask you a question. The question is, both of these answers are 4 pi. Does that mean that the circumference and the area are equal to each other? No, circumference cannot be equal to area. It's impossible. And the reason why is because these are inches. These are sticks and these are squares. Sticks and squares cannot be equal to each other, even though the numerical part here is exactly the same. All right, so going back up here to question number 21, where you're going to apply the circumference and the area formula. I do believe that this one has to do with, like, say, finding the circumference and finding the area, and they give you a diameter. So fairly straightforward kind of application of those two formulas.